How's it going? Welcome back to Dylan Pickup's blog. I want to thank the gentleman who sent in a question through Facebook last night because he has inspired today's blog. A very interesting question. Telecaster pickups, especially. We'll talk about two different aspects. He had two things to his question. One, does the metal bridge that surrounds the pickup in a Telecaster, the ashtray bridge, does that have any effect on the tone? And then an extension of that to his question was, do the materials that a pickup is made out of have any effect on the tone? So let's get into it. This is going to be pretty interesting. You are making me work for this one. Let's talk about what is known as an eddy current. Okay? This is a very interesting concept. An eddy current is, so this is my crude bottom base plate of a Telecaster pickup, and pictured also here, and here's the bridge, and here's the center of the pickup. Anytime there is a metal plate, a metal surface that is perpendicular to the polarity of the magnet. So we have north here, south here, and this plate is perpendicular to that magnet. What can happen, as long as that plate is within that magnetic field, is that something called an eddy current can develop. An eddy current means a current in the shape of a spiral. Okay, and what happens is that current, as the magnetic field changes, and that's very, very key, as the magnetic field changes, or the voltage in the wire in the coil changes, that eddy current can develop and fall, rise and fall, rise and fall. And what can happen is it can reach up into the coil and up into the magnetic field. Now, anytime we change the efficiency of the magnetic field or of the coil, it's possible that we can change the tone of the pickup. What do I mean by changing the efficiency of it? I'm going to demonstrate for you. This is actually really cool. What happens, what eddy currents do. So this is a very crude example, but here we have a wooden cutting board. We have a piece of aluminum. Now, aluminum is a non-ferrous material. This doesn't even have to be steel or, like a ferrous material. So this is a non-ferrous material and a piece of wood. And we have a very, very strong magnet. I did this to exaggerate the point. It probably wouldn't have worked. In fact, it didn't work with a pole piece from a pickup. I had to use a really, really strong magnet. In fact, this is one of the magnets that we use to actually magnetize pickups. So I'm going to explain something to you. Or show you something really cool. So if we slide this down, they're the same angle, obviously. You see the speed in which the magnet falls down? Watch this. That is not a magnetic surface. And yet, that magnet kind of sticks as it goes down. That is because as the magnet moves across the metal surface, even though it is not magnetic, it causes eddy currents, those spirals, to move in opposition, more or less, to the magnet, causing it to stick as it comes down. Now, the reason this is significant is because when we go back to our pickup design, when we have that sort of interference within our coil windings and within our magnetic field of our pickup, and then we strike our string, and we have a force that is moving in opposition to the magnetic field or in opposition to the electrons, because this is all happening even in the wires. It happens everywhere electricity moves through metal. So if you have a force that is moving in opposition to what you're trying to do, which is move electrons, then technically it could, okay, it could affect your tone, because we are affecting the efficiency of the pickup because it's pushing against what you're trying to do. Here's the interesting thing though, there's a few factors. One is the distance of the metal surface from the magnet. Two is the, so we have a lot of distance here, we have about a ½ inch, right? Because there could be eddy currents on the bottom of this bridge happening, and it could be messing with the tone as the current or the voltage goes through this part of the pickup. But it's about a ½ inch away. Down here we have 90 thousandths of phenolic underneath here, and then we have a little bit of a gap in the metal thing, so there's a little bit of a gap there. On a humbucker pickup we have a cover, but it has a little bit of a gap on the inside, so how much eddy current really are we left with? This formula over here, I know you probably can't understand it. I figured it out this morning, but we won't get into that because I don't do calculus on days that end in Y in videos. So, but basically, the bottom line of this formula right here is to show us that the further away from the magnet the metal surface is, whether it be the bridge of the Telecaster, the cover of a humbucker, or the base plate of the Telecaster, the further it is away, the less of an effect it has, and the less possibility that it has to make eddy currents. The other thing is that the higher the frequency is, the less it is possible of making eddy currents. Most of the time you're worried about this in like electric motors and stuff at 60 hertz. We're talking about 1K and above, so most of the time. So, you know, 1K being the center anyway. So those factors mean that it is less of an effect. The interesting part about this equation though is that there is a factor where it like affects it, causes eddy currents, a little bit less, then all of a sudden it like falls off where it doesn't have any effect at all. And it's not actually very much. I'm going to show you another demonstration. I kind of mocked this up earlier. So we'll take our same demonstration. But this time we're going to take the bottom piece of flat work from a Stratocaster. In fact, let's do this ahead of time. So alright, so there's your rate of dropping. So now let's take the bottom piece of a Stratocaster pickup, and then let's drop it again and see what happens. It falls, okay? Now it still sticks a little bit more than it sticks over here. But I just wanted to show you that, to show that in the 90 thousandths inch that it takes to get to set that off, that magnet off of that piece of metal, those eddy currents are by a large percentage less present. Okay? And the other thing you have to remember in this experiment is this magnet is way stronger than any pickup ever has, because this magnet right here is, well, it's wicked strong. So when we scale that back to an Alnico 3 pickup and we have 6 small pull pieces in a row in a Telecaster pickup, the factor is even that much less. This equation shows that you don't have to move it very much, and that demonstration we just showed shows that you don't have to move away from the magnet very far for the effect of the eddy current to fall off greatly. Does that mean that the bridge in the Telecaster pickup being up next to the magnet has no effect at all? Probably not. It probably still does have present some eddy currents there. And this one on the bottom of the Telecaster pickup, you know, the steel base plate or the copper base plate, depending on which one you use, and the material actually makes a difference in that, probably does have, there are probably some eddy currents present. But you saw with 90 thousandths of an inch in between there, with a very strong magnet, and the 90 thousandths of an inch is the same thickness as the bottom of a tele pickup, how much less the effect was. So are they present? Absolutely. How much effect does it have once you move it a ½ inch away from the bridge? That's really hard to say. How much of effect does it have when you move it 90 thousandths away, the metal plate away from the magnet down here? We saw the effect was a lot less. So when we go back to, does it affect our tone? That is going to have to be something that you experiment with, because we're dealing with factors that are so minute and so hard to duplicate in every situation that it's difficult for me to say yes, it has an effect, no, it doesn't have an effect. But we can see that they are present in the guitar. So what does that mean? Well, it means if you're building a guitar completely from scratch, do you want to experiment with different style bridges? I would take the time and do that. Does it mean that you want to experiment with a copper plated bass plate versus a steel bass plate on your Telecaster pickup? Or you want to try one or the other? Remember, there is nothing absolutely right or absolutely wrong, because when we say does it have an effect on the tone, what does that compare to? It doesn't necessarily make it worse, it doesn't necessarily make it better, it just makes it different. So just remember that when we're trying to make these decisions. So, I know it was a complicated one. It's pretty cool though. And I think just for fun, we should slide that magnet again, because that's pretty cool. So in our little experiment about sliding magnets down and understanding these eddy currents, I thought I'd do something a little interesting. I'm going to take the two most common magnets that are in humbuckers, and we're going to try something. You saw how slow that Neo magnet slid down here. It was a very strong magnet. Okay, so now let's take an Alnico 5 bar magnet that we use in a humbucker. So there's how far it slides down there, how fast it slides down there, and there's how fast it slides down the aluminum. Compared to the really strong magnet, obviously we would have to say that there are less eddy currents present. Not to say that there isn't any, but there is definitely less. Now, let's have a race, for lack of a better word, between a 3 and a 5. No perceivable difference. So, again, are there eddy currents present? Probably, that we can't detect in our little goofy experiment here. But it's just interesting that we have to exaggerate it a lot to be able to make a perceivable effect in our experiment. It just makes you wonder how much difference it makes in your tone.